I welcome you all to the second session of CodeCrunchers. I hope you enjoyed the first one and went through the notes. And before we begin, I would like any one of the candidate to kindly brief me about what we learned or studied yesterday. Learning and practicing Java is totally based upon regular and consistent practice, and that's why I request any one of you to kindly raise your hand so that I may unmute that candidate and brief me about what we studied yesterday. Okay. One candidate has raised his hand. Let's unmute him.
Hello, am I audible?
Yes. So
Good
you're going to
morning
brief
to
us.
everyone.
Good morning. So you're going to
Yes,
brief us today.
yes, I will try my best.
Okay. So
So,
start.
should I give a whole revision what we did yesterday, or just data types?
Basically, what we did in the second part, because the first part, I guess I guess it was you only who briefed. So
Yes, it
second
was
part
me.
we did about data types and variables. That part you can just brief once.
We did variables in Java and Java data types, and in data types we did primitive data types. So I will start with variables in Java. Basically, variables in Java is container for storing data values. It allows the program to store and manipulate data. Uh, then we have Java data types, which are further divided into primitive and non-primitive. In primitive, we have integer data types and then floating point data types. In integer, we have byte, short, integer, and long. And in floating point data types, we have float, double. Integer variable are used to store whole number values. For example, if we take a value like INTA, then it will only store a whole number value. And for decimal value, we use double. That's what I know.
Okay, that's great. We also did about char and boolean. So okay, so now I'll just give a quick recap of what we did yesterday, and then we'll continue. Wait for a second. I'll just share the screen. Just a quick recap. First, yesterday I introduced Java. What is Java? Which type of computer language it is? I told it is a high level language. It is an object oriented programming language. That is, it works by by creating objects, and it is user friendly. It is simple. It is platform independent language. That is, you can write once the code and can run it anywhere. It is a secure language. It is easy to troubleshoot. Then we did the four pillars of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Encapsulation was the bundling of data into a single unit known as class, bundling of the whole program, the whole code. Abstraction was hiding the complexity and just revealing the essential details. Inheritance was the reusability feature, reusing the code from another class, like you can just inherit the data from one code to the other. Polymorphism was that many forms of one interface, reusing the same thing with for different functions. Then we did class. Class was a blueprint which was used to create objects. In that we write the codes and its different instances were the objects. I told the example of colors. Were a class, and red, blue, the individual colors were objects of that class. Then we did variables. Variables, I said they were container boxes for storing data values. They allowed the program to store the value of any data that we input into it, and it can also manipulate that data for addition, subtraction, multiplication, any operator if we use. Then I said about data types. Data types, we specify the type of data. Now here I'm putting emphasis because data types, it is very important that it should be clear. Okay, so data types, they are basically of two types in Java: primitive data types and non-primitive data types. Yesterday, we completed primitive data types, but I'll just revise them once again. Primitive data types are of 4 types. Number 1, integer data type. They are basically of 4 types. Byte, like he said, short, int. It is int, not integer. If you write integer, then the program will not run. It is int, and long. The size of byte is 1 bytes, that is 8 bits, because 1 byte of storage is equal to 8 bits of storage. The size of short is 2 bytes, that is 16 bits. The size of int is 4 bytes, that is 32 bits. And the size of long is 8 bytes, that is 64 bits. The default value, it is on your screen, 0 for all. These 4 data types, which I just now said, byte, short, int, and long, they are used to input whole number values. Now coming to our floating point data types, that is float and double. They are used to store decimal values of numbers. For example, if I want to store 1.532, or if I want to store the value of pi, 3.14. So all of these can be stored into float and double. And I would recommend the usage of double because it can store a higher value. Now char was used to store characters. It has a storage capacity of 2 bytes only, that is 16 bits. We can store characters, any of the alphabet, any of the number as a character, not as a number. And then Boolean was for conditional programming, I told yesterday. Now today, we will first do one of the non-primitive data type, that is string. And then we'll continue with what we had to do today. Okay. String. String is a non-primitive data type, and it can be the most used data type in Java when we are not talking about integer-based programming. Integer-based programming as in programming which uses numbers. If we want to store our name, if we want to store a sentence, then we have to use this non-primitive data type, that is string. So for example, if we want to store a name or a sentence, then we will be using string, because char data type was for storing just a single character. And if we want to store a group of characters, for example, if I want to store code crunchers, so I'll take a variable. For example, I took a variable A. Then I'll input into that variable the name code crunchers. Because today we'll be understanding the structure of a program, so I have written here a syntax, a snippet of a code on entering a number, a data value into a variable. So I'll just explain it. Here I wrote string. So string was the data type. We are informing the Java compiler that the value to be stored in the variable A will be a name, will be a group of characters. So that's why we used string. String was the data type. It is a non-primitive data type. That is, it has been used to inform the Java compiler, to inform the Java machinery that the value to be stored in this variable A will be a string, will be a group of characters. Okay. So that's why we wrote string before the variable. Then this A is the name of the variable. I can take any name. We'll do the rules for naming such variables, but I can take any name as of now. First, we'll understand this thing clearly, then we'll go to the other topics. So string, it is the data type which is informing the Java machinery that the value of data to be stored in the variable A is and will be a string, that is a group of characters. Then we stored code crunches into it. Now, many of you might be wondering what is the need of these double inverted quotes and then this semicolon over here. So here's a very important thing. Whenever we are going to input a string I repeat, whenever we are going to input a string, that is a group of characters in a variable in Java, we'll always be enclosing it. We'll always be writing it in double inverted quotes. Hope it's clear. And then about the semicolon, semicolon is just like a full stop. In English, we apply a full stop at the end of every sentence, at the end of every sentence that we write. Similarly, in Java, we apply a semicolon at the end of every sentence. Every sentence, as in every command, every input that we make, we apply a semicolon in Java when we write the code. Okay. So hope it's clear why we used string over here, why we used this a was the variable, string is the data type, why we use this double inverted quotes. Then code crunches was the thing we have to input. Then why we use the semicolon. Hope it's all clear. Kindly inform me in the chat box. Then we'll continue. Okay. A very good question. The reason we used a over here. See, I wanted to store a string code crunchers. I wanted to store code crunchers in the program. Then yesterday when we were doing variables, I told that variables are like containers which are used to store data values. So I had named a variable a. Just like in math, we take x as the unknown quantity. Similarly, I took a over here, and please note this a is a lowercase letter. I took a over here to store the value of code crunchers, to store code crunchers in it, so that if I want to do any operations on this word code crunchers, then I can just means call a and then do all of the operations. I can print it, I can do anything which the Java compiler allows. So this a over here is the variable which is used to store the value of code crunchers. And before a we wrote string, that is the data type of a, means it is informing the Java machine what will be the type of data which will be stored in this data box in this variable a. So a was the variable. We can use anything. I can write string b is equal to code crunchers. I can write string ab. We'll come to all of these rules just after it. So I hope it's clear that a is the name of the variable. I can take any name, just as in math. I can take x to be the unknown quantity. I can take y as the unknown quantity. Hope it's clear. Okay. So now first we'll be doing the rules for naming the variables, because here I took the name a. So what are the rules which govern which type of combinations we can take as a variable and which type of combinations we cannot? Hope the data types was clear, and as and when we'll be using it in a programming, it will be more clear. Day by day you'll get used to these data types. Okay, so here are some important rules for naming the variables. The first one being, it must always start with a letter, an underscore, or the dollar sign. That is, any variable I take must always start with either a letter or underscore or dollar sign. Except these, if I start a variable with a number, then the Java compiler will not consider it as a variable and your program will not run. Variables must always start with a letter, underscore, or a dollar sign. I hope that you all are noting it in your notes. Variable, that is, just now we used a as the variable when we stored code crunchers. So means variable can be a single character also. Variable can be a group of character. For example, I can take a variable as string name. It starts with a letter, so it is a valid variable. It cannot start with a digit. The second point, if by chance we would have started it with a digit, then the program would not have run properly. Now the third point, it is a very important point. We cannot use Java keywords as variables. Now what are keywords? I'll be writing the definition here. Kindly write this definition. Keywords are words or characters which have a special meaning to the Java compiler. Compiler is the translator in Java which translates the program, the code to completely computer language for the computer to understand. So there are certain words, like for example, it is int, the data type we did. Int was the data type we just did, which is used to store whole number values. So we cannot name a variable as int because int already has a special meaning to the Java compiler. and hence it cannot be used as a variable. And it is highly recommended to use meaningful names. For example, if I want to store a number, or if I want to store the sum of two numbers, 5 plus 4, then it is highly recommended to name the variable as sum, S-U-M. For example, if I am going to read the code, then it would be easy for me to understand what is this variable used for. If you wrote int sum is equal to any number, then just by seeing the name of the variable, I can deduce that in this variable, you are storing the sum of some numbers. Okay. So the last point is use meaningful names. It is not obligatory, but it is recommended to increase the readability of the program. It would be easy for me to understand what is the value storing in that variable. And the most important point, which we'll be talking in great lengths and breadths today, is this fourth point. Hope you have copied all of this, the definition of keywords, then all of these rules. Then I'll just clear the screen. Okay, now it's time for the break. I request you to kindly go through all of these rules in the break, hydrate yourselves, and then after the break, we'll come to case sensitivity of Java. And then today we'll be introducing you to the structure of programs. Okay, so that from tomorrow onwards, you'll be able to construct your programs easily. Okay. That's all for this part. We'll meet at 11 or 10. Okay. I request you to go through the notes in this 10-minute period and then rejoin the session. Hope you all went through your notes in the break, rehydrated, and revised everything. Now we'll come to the new topic, case sensitivity in Java. So the fourth point for naming variables was case sensitive. What is this case sensitivity? Yesterday I told you something that in Java, two variables, lowercase a and uppercase a, that is small a and capital A, they are not equal. For example, if I use a variable int a is equal to 5, I stored a number 5, and then afterwards I called the variable a for any function. Then the Java machine will show an error because Java is a case sensitive language. If I have stored the value in lowercase a, then I have to call the same variable, which is lowercase, to do different operations on it. I cannot call the uppercase equivalent of that variable. That is, if I've stored a value in lowercase a, I will have to call lowercase a only. I cannot call the uppercase a. Now, the thing we did, we know that we can use any combination of characters as a variable. The only thing is it should start with a letter or a dollar sign or the underscore symbol. It cannot start with a digit. We cannot use Java keywords. For example, we cannot use int or class as a variable because all of these words have a special meaning to the Java machine. If I've stored a value of 5 in int and that a is uppercase, so I will call the uppercase a only for doing different operations. I cannot call the lowercase a now because lowercase a and uppercase a have different values. I'll just recap once. The Java is a case sensitive language, and for it, if I use a variable small a or lowercase a to store a value, then I cannot call the uppercase a to do operations on that same value because for Java, both these variables are different, completely different entities. If we have taken uppercase a, we have to use uppercase a throughout the program. If we have taken lowercase a, we have to use lowercase a throughout the program. In Java, it is a case sensitive language, and hence if I'm using a variable or any keyword and it is in a lowercase, then I cannot convert it into uppercase and use it because it will show error. In Java, lowercase and uppercase characters are taken completely differently. They are not taken as equals. Hope that's clear. Okay, that's great. And now I'll introduce you to the structure of program, the first program. Okay, now we'll be moving to the structure of a first program. Okay, so there was some problem with the whiteboard. I'll be writing the code here because this will be using in your PCs to run your Java programming. It's called BlueJ. For beginners, it's the best thing. So the first thing, first I'll write the whole program, then I'll explain it to you line by line. For the structure, I'll be doing the simplest program. Okay, that's great. Now considering these codes, keep up with your notes and listen attentively. the first line which I wrote, it's class F. So what's this class? Remember when talking about encapsulation, I told that the wrapping up of functions into a single unit called class is known as encapsulation. So this is the unit class in which I am writing the whole program. So the first line will always be class with all the alphabets to be in lowercase. All of these 5 alphabets will be in lowercase. And then the name of the class I have taken as F. You can take any name, class hello world, class first program, anything. Just the thing is you should not leave white space in the class name. That is, your class name can be 2 words without a blank space. Blank space cannot be used in class name. Okay. Then the second line, I have opened a curly bracket. Okay, this is the basic structure of a program. And for all the programs, after writing the class and the class name, you have to open a bracket. It specifies the area of the whole program, because I've opened this bracket over here and I've closed this bracket at the end. So it specifies that the bundling of the code is to be done from this point all the way to this point. Hope these first 2 lines are clear. Kindly first inform me, then we'll go to the third line. Okay, class is the keyword. It has a special meaning to the Java compiler. So this was about the first 2 lines of the program. Now there's this third line. This third line consists of 4 words, and these 4 words, until you get to a good level, you have to keep using these. It is just like a phrase you have to remember. It says public static void main. Public specifies the accessibility of this program. This static keyword and then void main. So this whole line you have to just like remember as it is. After that, there are 2 brackets which are opening and then closing as soon as they are opening. So the third line, it should be remembered as it is. So public static void main, and then again we are opening a bracket. Now this public static void main, the bracket which we are opening, this curly bracket, we have to close it just before we close the class bracket. And the whole code, it comes in the public static void main section as of now. So the bracket will open after public static void main. We are going to close it at the end of the code, just before we close the bracket of the class. The whole code must be encapsulated in this block only, and this block in turn is encapsulated in the class block. Hope it's clear. First we wrote class, then the name of the class, then we opened a bracket to specify the whole part which is to be encapsulated in the block of the class, and then we wrote public static void main. We opened a bracket to specify the whole block which is to be encapsulated or which is to be written in public static void main. And for your knowledge, the whole of the program must always, until you reach a good level, must always be in the public static void main group only. Its bracket must always be closed just before we close the class bracket. For now, you have to use public static void main, and generally we use public static void main at an intermediate level also. We are using public static void main only. So this is just like a phrase you have to remember. I explained this phrase, and this is just like a phrase you have to remember and write at the third line of the program. Now here in this program, I have stored the value of 5. I have stored the value of 5 in a variable a, and I've specified the data type of a as int, as you can see over here. I have stored the value of 5 in a variable a, lowercase a, and I specified the data type of a to be int. That is, it has informed the Java compiler that the value to be stored in a is going to be a whole number. Hope this line is clear, because this variables and data types we have talked about it in great length and breadth. Kindly inform me if all these lines are clear. Okay. So the storing of value is known as, or the initialization of a variable is known as initializing the variable. So we have initialized this variable a with the value of 5. And now the final part of this program, this is the simplest program I could have made. So the final part is this line. Whenever I want to print anything in Java, I want to get an output, then I write this line: system with a capital S, uppercase S, dot out dot print ln, and then I write the name of the variable, write the variable, in the brackets so that the value of the variable gets printed in the output. And I've written this variable a in the brackets of system.out.println, which specifies that the value of a will be visible as the output. Is it clear up to here? Then we'll compile the program and go to the output. Kindly inform me. No, a is the variable. And in variable a, I have stored the value of 5. And I want the program to give an output, and in the output, the value should be 5. I want the program to give the output, and I want the program to, in the output, to print the value 5. So I had already stored the value 5 in this variable a, and hence I've just written a over here in this bracket, which specifies that 5 will be printed because the value of a is 5. We have stored a is just the variable. So when we are running the program and getting the output, so in the output we'll get the value of the variable. Hope that's clear. Okay, that's great. It's clear because variables are the basics of programming. That's why I talked about variables a lot yesterday and today also. Now I'll just compile this program. See, compilation just converts this program. It easily translates it into the Java virtual machine language. I'll just compile this program, and then here you can see at the left corner, it shows class compiled, no syntax error. After compiling the program, if this message comes, it means that your program is 100% correct. If you talk about its syntax, if you talk about its grammar, it's 100% correct. Here it's written class compiled, no syntax error. So we can say that this program is accurate. And now I'll show you the output. But before showing the output, one more important thing. As I had already explained to you, the use of this semicolon, it's just like the full stop. So after the printing line, I've typed a semicolon. After the initialization of variable a, I've typed a semicolon. After every statement, we must type a semicolon. And note that I have not used a semicolon over here, neither have I used it over here, because this was the class name. Here we do not use semicolon. This was the specifier to specify and for us to enter in this block the whole coding, and that's why we have not written any semicolon over here. Semicolons are always after statements, like after initialization of variables, after the printing statement, and so on. So I'll just show you its output. Yeah. So this was the class F which I had created. Here's the code you can see over here. This was the class F I had created. I'll just right click on this class. I'll click on void main because we did a public static void main. So I'll click on void main, and here's the output 5. Today you only need to understand the basic structure of the program. That is, first we write class, the keyword class, the name of the class. We open the bracket, we write public static void main, and then we open the bracket for the code. We write the whole code. For printing, we write this system.out.println. In the bracket, we write what we need to get printed. We can also get a message printed over here that we'll do tomorrow. And then we'll just close the bracket of public static void main so that this whole code is encapsulated within public static void main. And then we close the bracket of the class to bundle up this whole program into a single unit, that is class. How to get this program, how to open this program, how to get the output. All of this we'll come to it tomorrow. The only thing I wanted you all to grasp today was the basic structure of a program. What we must write in the first line, class, the keyword class, its name. What we must write in the second line, the bracket we have to open for the block of class to get opened. What we must write in the third line, public static void main with 2 brackets. What we must write in the fourth line to open the block of public static void main, and then the whole code to be written. And then to print what we want to get printed, system.out.println. I wanted you to get familiar with these phrases today. And then to close the block of public static void main. And then finally to encapsulate and close the block of the whole program into class. So hope this basic structure of program is clear. Kindly inform me if it's clear. Okay. So we'll keep up till here. Tomorrow, we'll do maybe 2-3 more programs to get you familiar with programmings. Okay. Hope you enjoyed today's session. I'm keeping it up till here only. I request you to kindly go through your notes today, and if you have any doubt, you may ask it tomorrow. Thank you.